Hello everyone. In today's class, we will talk about complex number theory. So let's proceed further. So first of all, what is complex number? A number of the form a plus ib is known as complex numbers, where a and b are real numbers and I equal to root over -1. Here a is called the real part and b is the imaginary part. As an example, z equals to 2 plus 5i. Complex number is often denoted as Z. Now, some basic operations of complex numbers. First of all, addition of two complex numbers. If Z1 equal to A1 plus IB1 and Z2 equal to A2 plus IB2 be two complex numbers, then Z1 plus Z2 equal to A1 plus A2 plus I into B1 plus B2. Here is an example. Z1 equal to 3 plus 5i and Z2 equal to 5 plus 6i. Therefore, Z1 plus Z2 equal to 3 plus 5 plus 5 plus 6 into I equal to 8 plus 11i. So, it is very clear that while we add two complex numbers, the real part of first complex number is added to the real part of the second complex number, and the imaginary part will also be added respectively. Now, subtraction of two complex numbers. If Z1 and Z2 are two complex numbers, then their subtraction can be defined as Z1 minus Z2 equal to Z1 plus of minus Z2, that is addition of Z1 and minus Z2. Here is an example. Z1 equal to 5 plus 3i and Z2 equal to 3 plus 2i. Therefore, Z1 minus Z2 equal to Z1 plus of minus Z2 equal to 5 plus 3i plus whole bracket minus 3 minus 2i equal to 5 minus 3 plus whole bracket 3 minus 2 into I equal to 2 plus I. Now, multiplication of two complex numbers. Multiplication of two complex numbers Z1 and Z2 can be defined as Z1 into Z2 equal to A1 A2 minus B1 B2 plus I whole bracket A1 B2 plus A2 B1. Here an example is also given. Very simple. Now, properties of addition of complex numbers. First of all, commutative law. Z1 plus Z2 equal to Z2 plus Z1, where Z1 and Z2 belongs to C. Associative law. Z1 plus Z2 plus Z3 equal to Z1 plus whole bracket Z2 plus Z3, and distributive law. Z1 whole bracket Z2 plus Z3 equal to Z1 into Z2 plus Z1 into Z3. Now, properties for multiplication of two complex numbers. First of all, commutative law. Z1 into Z2 equal to Z2 into Z1. Associative law. Z1 into Z2 into Z3 equal to Z1 into whole bracket Z2 into Z3. Distributive law. Z1 whole bracket Z2 plus Z3 equal to Z1 into Z2 plus Z1 into Z3. Now, conjugate of complex numbers. If Z1 equal to A plus IB and Z2 equal to A minus IB are two complex numbers, then Z1 and Z2 is called conjugate of each other. Conjugate of a complex number Z is denoted by Z bar. Here is an example. Z equal to 3 plus 2i. Therefore, its conjugate Z bar will be 3 minus 2y. Some important notes. If z and z bar are two complex numbers, then z bar whole bar equal to z. 2. Let z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2. Then z1 plus z2 whole bar equal to z1 bar plus z2 bar. Next, z1 minus z2 whole bar equal to z1 bar minus z2 bar. Next, z1 by z2 whole bar equal to z1 bar by z2 bar. Next, modulus of a complex numbers. If z equal to x plus iy is a complex number, then its modulus will be mod z equal to root over x square plus y square. An example is also given. Let z equal to 3 plus 5i, then its modulus mod z will be root over 3 square plus imaginary square, that is root over imaginary real part square plus imaginary part square equal to this. Now, properties of modulus of complex numbers. Mod of z1 minus z2 less equal to mod z1 plus mod z2. Mod z1 minus z2 greater than equal to mod of mod z1 minus mod z2. Mod of z1 into z2 equal to mod z1 into mod z2. Mod of z1 by z2 equal to mod z1 by mod z2. Next, amplitude or argument of a complex number. Let z equals to x plus iy is a complex number. Then the value of phi for which the equation y by x equal to tan phi will satisfy. This value is called amplitude or argument of z. An important note, there may be infinite number of arguments of a complex number. Now some remark. Among the values of phi for which minus pi less than phi less or equal to pi will satisfy, that will be called principal value of argument, and it is denoted by amplitude of z or argument of z. Remark. Since cos of 2n pi plus phi equal to cos phi and sine of 2n pi plus phi equal to sine phi, where n is any integer, therefore if the value of argument of z is phi, then phi equal to 2n pi plus argument of z. On the next video, we will continue the lecture of complex series and we will solve some numericals related to complex numbers. Thanks for watching.